Good morning. We are going to try another example for section 4.4, solving trig equations. We have ourselves a trig equation here. 4 secant x plus 8 is equal to 0. We're asked to solve it over this domain in degrees from 0 up to, but not including 360 degrees. So in my first example, I went through the 4 steps that we need to go through to solve a trig equation. The first step was to isolate the trig ratio. And in this case, we're talking a secant ratio. So that would be my first step. So when I go back and I look at my equation, the first thing I'm going to do to get secant x by itself, I'm going to move the 8 to the other side. So I have 4 secant x is equal to negative 8. And getting rid of the 4, divide by 4, I have secant x is equal to negative 2. So I've isolated the trig ratio, which is step number 1. Step number 2 is asking us to draw the diagram. But before I do that, even though I have the trig ratio by itself, what I'd actually like to do is switch up to its reciprocal partner. I'd like to focus on the ones that I'm most comfortable with, which are my primary trig ratios if I can. And so what I'm going to do is I'm going to take the reciprocal on the left side, and as with equations, when you take the reciprocal of one side, I need to take the reciprocal of the other side. And so what I am going to be working with is cosine of x is equal to negative 1/2. And the reason why I want to do that is simply because when it comes to my second step, where I'm drawing my diagram, talking about where my angles are, my trig ratios are positive and negative, I'd rather work with the ones that I'm, again, most comfortable with. Cosine is a negative ratio in this particular equation. And so what that means is when I look at my diagram, I'm not talking about where they're all positive or where cosine is positive. I'm talking about the other quadrants where cosine would be negative. Now, so I know I'm going to end up having angles in quadrant 2 and quadrant 3. And according to our domain, I can only go in the positive direction. So I'm going to have an angle here. And I'm going to have an angle here. So I'm expecting 2 solutions to my equation for this particular domain. So let's go on to step number 3, where we are going to find our angles. So we're talking about finding theta. And again, when I talk about whether I'm asked to find an approximate answer, an exact answer, a lot of times it goes back to the ratio that I have. And the more experience you have with the unit circle, the more these numbers are going to stand out to you. So negative 1/2 or a half is a unit circle number. So what I'm going to do in this case is I'm going to find my angle using the unit circle. Because we're talking cosine is about x values. So when I bring up my unit circle, I'm going to be focusing on where x is going to be a negative 1/2. My diagram should give me a clue as to which quadrants I should focus on. But again, I'm going to make sure that I am looking for where the x value is negative 1/2. So let's just bring up the unit circle here. All right, so x values, there's a positive 1/2. Here is where we have ordered pair, x is negative 1/2, and down here. So the angles I'm looking for are these 2 angles, 120 degrees and 240 degrees. That's both of the angles that I was looking for. So when I talk about step 3 and step 4, oftentimes my angle, the 120 degrees is kind of the first one that we would find, and the other angle being the 240 degrees. Okay, now when I talk about that other angle, I often will say that because if you are not using the unit circle, and again, both of these angles I took off of the unit circle. Let's say that you did not recognize the cosine of theta or x being negative 1/2. You didn't recognize that as a unit circle number. What if you went straight to using your calculator and you were working with cosine of x equaling negative 1/2? Most likely what you would have done is go back to what we've done in the past. When we use our calculator, you would need to do cosine inverse to get rid of the cosine so that our x is by itself. And so in the calculator, you would be putting in cosine inverse of negative 1/2, and that would give you a solution. I'm going to just bring up my calculator and show you what that would look like. Again, now I'm working in degree mode, so I need to make sure that my calculator is in degree mode. It's not, so I need to go down, move over to degrees, hit enter. So I am now going to, I just want to clear all this. There we go. Yep. All right, so if I'm going to punch into the calculator cosine inverse of negative 1/2, second cosine of negative 1 divided by 2, close my bracket, and the answer I get is the 120 degrees that we had already had. So I do have the 120 degrees out of the calculator, but it's the other angle that I'm not seeing on the calculator. And so for me, the unit circle is a preferred way of finding my angles and the other ones, because otherwise I'm not seeing that second angle, that 240 degrees with the calculator. Now, the reason why we can use a calculator, but it involves a little bit more work. Once you recognize that the 120 degree angle is one of your solutions, you would need to talk about reference angles of the 120 degree angle, which would be 60 degrees, to help you get the second angle, which also is going to have a reference angle of 60 degrees. So if you are using the calculator to find these angles, then you would have to think about the reference angle is 60 degrees, so that you would end up being able to find the quadrant 3 angle as being 180 degrees plus the 60 degrees reference angle, and you would get your 240 degrees answer eventually. Your initial angle, your other angle with a calculator. So it's just a little bit more work. The unit circle is a little bit more obvious as you're looking at the unit circle, and you can see those solutions. So in this particular example, we needed 2 solutions. The last step, I talk about doing a check. And in this particular equation, the fact that it was 4 secant x plus 8 is equal to 0 means that when we go to substitute in our solution, for example, the 120 degrees, and we want to see if the left side is equivalent to the right side, we don't have a secant button in our calculator. So what I would end up needing to do is replace the secant of 120 with its reciprocal partner. 1 over cosine, same angle, 120 degrees. So if I'm going to check this solution to see if it is going to equal 0, I'm going to put this into my calculator and see if it does give me the 0 that is on the right-hand side. So where's my calculator? And so again, in degree mode, I'm going to go 4, open a bracket. It was 1 divided by, now I need to make sure that this is all together, cosine of 120 degrees, close a bracket for the angle, close a bracket for the fraction, and then it was plus 8. And yes, it gives me 0. So that means that I have 0 on this side, 0 on the left side, and so that checks. Now I would need to do that again with my, not just my 120, but I would have to do it with my 240 degree solution to make sure that all is correct. So this equation asked me to work with a reciprocal ratio. So I wanted you to see how we would deal with a reciprocal ratio. I also had an opportunity with this example to see how we would get our solutions from the unit circle, or if you were going to use the calculator, how we would end up needing to get our two solutions when the calculator only really gives you one. And then, of course, our check. So that's a second example of a trig equation and solving it, and we'll see a few more. Thanks very much.